Yeah, thank you for the reminder. I had put it on pause, waiting for you guys. Had put it on pause, waiting for you guys. So yeah, so I've started recording because if most of the time if it's recording while I haven't yet started teaching it, the video becomes really big. Yeah. So thanks for that reminder. Um. Yeah. So what I was saying that we're going to look at the déplacement élémentaire under coordonnées polaires. So the déplacement élémentaire actually is really important because it will permit you to calculate the surface area of this point, which is moving. Yeah, for is under coordinates polaire dans un plan, you can only calculate the surface area. Why? Because there's only x and y axis. There are no point, or there are no 3 points, meaning you cannot calculate this volume. You know, for you to calculate the volume, you need this width, this breadth, this and length. Yeah, you need 3 what. So for you to calculate a volume of something, you have you can calculate the volume of a cube and yeah, a volume of a cube and the shapes which are in 3D, I can say so. But under coordonnées polaires, you cannot form a shape in 3D. You just form a shape in plan. So here you can only calculate each surface area, and I can give an example of a disk, yeah, of a circle which doesn't form 3D, or it's not in 3D, which has when I say 3D, I think you know what I mean, 3 faces. Yeah, so here actually the most important thing you have to know is what is the formulas, how to come up with the formulas, and the formulas actually they don't change. Yeah, they don't really change. They are the same formula. So if you know each formula for coordonnées polaires, you will know how to solve a lot of questions. Like if you just know the formula in your head, if you have the formula, you won't have any difficulties in anything. So the most important thing is you having the formulas, knowing the formulas. So where we've started from coordinates Cartesian, you have to know the formulas. So we're going to continue the déplacement élémentaire. So I'm going to I'm going to continue. So it says, on supposait que le point M subit un déplacement élémentaire. Donc it says, on supposait que le point M subit un déplacement élémentaire. So they're saying this point M, I think you can see this point M. We suppose that it has what? It has is subjected to what? To a displacement or to a movement élémentaire. Yeah, we suppose that it has moved and pour se retrouver en point M. So we see that we suppose that this point M has moved to point M what? Prime. It has moved to point M prime. So we suppose that, and they continue saying that ce déplacement élémentaire est représenté par les vecteurs. So they're saying that this displacement élémentaire is presented by the vector. So I think you know these vectors, which I talked yesterday, and I spent a lot of time explaining yesterday. So there's a vector E theta and the vector E rho. I think you can see the vector, there's the vector E theta, even though it's not really clear, and the vector E rho. So this point is what is represented by the movement of what? Two vectors, E theta and E rho. So we're going to look what happens when each vector moves. And I think I explained that one, like what happens when each vector moves. So here we're going to look it closely in terms of calculating the displacement of this point. Imagine this point M has moved to another point, which is another circle outside. It has moved to another circle outside. What actually has happened, or what movement does it follow for it to find itself at the M prime here. So that's what you have to understand. That's what you have to know. So if you know this, if you know how to interpret this diagram, I tell you and I assure you that you won't have any problems um, when it comes to coordinates, and you find the next topic very easy. So the reason why I'm spending much time on this is I want you to find the next topic very easy, because you'll be using the same things and you'll be just playing with these formulas. And actually, you'll find this really interesting to play with this formula. So the vectors which I'm talking about is E theta and E rho. So it continues here. Dans le rappel polaire, c'est M prime is equal to uh, déplacement or M, and E decomposé on the component. So here they're just saying that uh, here there's supposed to be M, or so we see here that the M prime is just equal to déplacement or M. It's just here they're just telling us that uh, the movement of you can either write it in M prime, the déplacement, the movement of M to M prime. That's what they are talking here. So don't let it confuse you. And you can also write it as DOM. So I'm going to continue. It says une rotation, variation de l'angle theta, c'est et on conserve le même area pour porter la direction de M prime. Then, so I'm going to explain the first point. So the first point, it says une rotation, variation de l'angle theta, c'est on conserve le même arc meaning the même radius pour porter dans la direction de M prime. So for me to, I want you to get me closely. I'll be a bit fast here, but it's something which is really simple. So I said that for me to have M prime, for me to move from M to M prime, I have to play with my two vectors, which is E theta and the E rho. So which one do I play with first? So there's a first one, the first vector which I play, there's there's E theta and E rho. So there's one which I move first, and after moving this one, I move the second one. So which one do I move first? That's the question. So I want you to get me close to get me yeah to pay attention here. So the first one which I move is what? E theta. So imagine you are seeing this point is here, point M. So for me to reach point M prime, what shall I do? So I shall move M to another angle, which is here. So I've moved theta. So you have seen this point M, it's moving on the same circle. If you have seen, this is a circle, it's presenting a circle. So the first thing is this point M will move on the same circle to reach here. When it reaches here, then now it will move out of the circle. So this is how the movement is. So how can I interpret this one? So the point M will move to the point N. If you are seeing, so the point M will move to point N. So what do you observe here? When this point M moves to point N, what do you observe? You observe that theta is the one which is changing. The angle, in other terms, is the one which is changing. But do you observe any changes in the distance or what? Or M? Is there any change? You see that there's no change because this point is still moving on the same circle. So this leads us to this equation where you see that there's rho. Rho is just the radius, which is constant. Then there's the changing. If you see the equation here, you have seen that there's rho. Rho, it means the radius between O and M is the same as the radius between O and N, which is rho. So you see that there's rho here times what is changing? D theta. D theta, differentiation theta is just, it means the angle is changing times d theta. Then you add this what is vector of direction, which is in the direction of E theta. So this is where this formula comes in. So this formula is the movement of M. So you see that M will move to n in the same circle, but so if it is in the same circle, I remember I told you that the distance ON is equal to OM, so rho is the same, and yeah, rho is the same, and you see that yeah, rho is the same, and you see that d theta what is only the angle which changes. So now, yeah, this is the formula which is rho times d theta. So when it reaches here now, it has to make another what movement. So what movement is it now? It's the movement of moving out of the circle. So this is the formula for it turning around it for the point M to move to the point N. This is its formula. Then now for for this point, which is here now, to move to M prime, it means what will vary here? Is it the theta or what? We see here that the theta, it will still remain the same because the theta is already moved. What will move here now is the rho. We see the change of the rho. We see that it moves, the radius changes in other terms. It moves to the outside circle. So you see that there's a differentiation of what? Rho. The change more of a rho, the changing of a rho. So we see that d rho, which is differentiation rho, e rho. So this is where the formula is coming from. So the movement from M prime is equal to d rho e rho plus rho times d theta e theta. So this is the formula where it's coming from. So this formula actually doesn't really change. It's always the same. Yeah, it's always the same. And this is if you're asked how does it come, this is how it comes, and this is yeah, this is how you can derive this formula. So this formula actually you can just be imagining this diagram for you not to have any difficulties. They tell you that the point moves from A to B. Yeah, under coordinate polaire. Find this word, find this, they can tell you find this vector M prime. You have to know how to find it. This is the formula how to find it. Yeah, so I don't know if there's any question here before we move on. I bet everything is clear.
Can you just go through this same part again?
What?
My network is bad. Can you just go through this part again, like quickly?
Oh, okay. Yeah, so I'll go. So here, the basic, the most important thing is you knowing how to derive this formula, MM prime. The movement, the déplacement élémentaire. So you know the déplacement élémentaire under coordinate Cartesian, you know it. If you check your notes, yeah, it's dx plus dy, something like that. Yeah, dx ex plus dy ey. So now it's under coordinate polaire. How do you find the déplacement of the element, déplacement élémentaire? So the movement from M to M prime. So I said that the first thing is this point M will move to point N, and yeah. So if you see the, if I said if you see if you can see how this point is moving. So when this point M moves to point N, you see that it's moving on the same circle, and you see that the radius ON is the same as the radius OM. Because why is it the same? Because it's moving on the same circle. So you see that your formula will have rho, which is the radius which doesn't change, times d theta, which is the change more of the what? The theta. You see, this theta has moved to like there's a change. There's a change here. Yeah, if you can see, this theta, it has yeah, it has a bit it has I can say it has yeah, it has uh uh for example, if it was a 60, it has become large a bit, where it has become maybe 70 or what. That's just an example. So you see here the movement of what? D theta. And the radius rho is just what? The same. Then after that now, So this is where this formula is coming from, rho times d theta e theta. Then after that, now this point which is on n will move to point m prime. So this is how the point moves. So when it moves to m prime, you see that the only thing which changes here is what? The rho. So that's why you see there's a d rho, which is differentiation rho, and the times is vector, which is it is moving what out. Yeah, it's showing that it's moving what out. So e rho, e rho. So this is where this formula is coming from: d rho times e rho plus rho times d theta e rho. I don't know if it's clear now.
All right, it's clear. Thanks.
Yeah. So yeah. So this is all about this
Uh, the
this.
question, the question.
Uh-huh.
My network, my network has, the question.
Yes, you can. You can ask.
My network has been jumping. So I was asking if you could give just like a brief explanation of what we've done like so far. Yeah.
Or oof. Because I'm from giving an explanation. Okay, I'll see.
Okay, maybe we'll catch up. I'll catch up. Maybe we go forward.
Yeah, I think the best thing is you just watching, because I'll be just repeating on the same thing, and we don't really have a lot of time. I'll just send the video.
All right. Thanks.
Yeah, I'll just send the video. But uh, yeah, yeah, I'll just send the video so that you can follow up. So now we're going to continue. So you have seen this is how we come out with this formula, and if they tell you to calculate its surface area, how do you calculate its surface area? Even though here in my notes we jump directly to what to we jump directly to coordinate Danzan space. So if they tell you calculate a surface area of a disk of of a disk, most of the time when they say a disk, you should know that you are using the formula for coordinate polaire. So they can tell you calculate a surface area of a disk. So for you to calculate the surface area, you have seen here, see, uh, for you to have the surface area, you have seen here is if you see this diagram here, it's making like a what? I can say, is it a square, a rectangle, but it's something like something which is similar to that. It's making, yeah, something like a square, I can say so. So if you have to calculate the surface area, it means you have to do this side, which is n prime, this side which is m to m n prime times this side which is m to n prime. So basically, you just get d rho. Don't when you're calculating surface area, don't include the vectors. Note, when you're calculating the surface area, don't include the vectors. You should note that one. It's really important. So d rho times rho d theta. So d rho is this change, d rho times rho d theta. This is how you calculate the surface area. So this is the formula to calculate the surface area. So for the surface area, actually, I had prepared something for you guys. I had prepared the question which we are going to just to look at first, so that you just have an idea. Yeah, you just have an idea. So I have to send. I have to send what? I have to send this PDF. I'll send it today. Yeah, I'll send it today. There was it's just the same as the first PDF, but I added something, and I corrected also something. Yeah, there was something like under, for example, Sukatoa. At last, we were supposed to have I saw it late that I'd put H that side. Sukatoa TOR. So I hope you can see my sharing.
Yes.
Okay. So I prepared an example for you guys. Since I know you understand better with examples, I guess so. So yeah, so under coordinate polaire, yeah, I think you can see this. There's an application. So one of the questions which they can ask you is they can ask you calculer de la surface d'une disque de rayonnement rond. So they say calculate the surface of a disk of rayonnement R, rayonnement rho, which is just the rayon is radius. Yeah, so of the radius what rho. So if they tell you to calculate the surface of a disk, first of all, you have to see what are they talking about. So the keyword here is a disk. When you hear the word they're saying about, they're talking about calculate the surface area of a disk, you should know that here I have to use the formula of coordonnées polaires. So how do you calculate the surface area? So for you to calculate the surface area, so don't get confused of r d theta and dr. So r is just the radius, which is just the same as rho d rho, and r d theta, rho d theta. So it's just the same thing, like it's just the radius. So d rho, you know that is the movement from here to here, and r rho d theta, meaning rho doesn't change, it's the movement from here to there. So for me to calculate the surface area, as I told you earlier, I said you should multiply d rho times rho d theta. So here rho is constant, what is changing is d theta, and here d rho is the one which is what changing. So for me to calculate my surface area, as I said here earlier, you just get the formula of the déplacement élémentaire, the mm prime, that formula which is which we are from looking at, which is d rho e rho plus rho d theta. So just get it. You just get you forget the vector, so it will be just d rho rho times d rho times d theta, and this rho is what constant. This rho is what constant. So you are trying to find the surface area of a disk. This is what a disk. You are trying to find the surface area of a disk. So how do you go about it? So for you to find the surface area of a disk, you have to do some integration here. You have to do some what integration. So the first you have to do some integration. So this is a double integration. I don't know if you know uh, I can say in English is double integration. Double integration, where you have to you have seen that there's two things which are changing. There's zero, which is changing. Zero is just the movement of the point from the inner circle to the outer circle. Zero, which is changing, and there's also d theta, which is changing, which is the movement from this point to another point here. So how do you calculate? So and you have rho, which is what constant. So how do you calculate your what now? Your surface area. So for you to calculate your surface area, you know that your what your double integration is the integration for the changing of the radius, and the integration for the changing of the what, the theta, the movement of a point around the circle. And you know that a point moves. We said that under coordinate polar, a point moves what 360 what around the circle. It moves 360 around the circle. So so here the movement it will be zero. Zero to what, to r, which is the radius, actually the radius, the maximum radius, and this radius can be you know, if this radius can we are presenting it in this radius can be between negative, it can be between 0 and what, positive infinity. So this is how you, most of the time, this is how you have to be like presenting it. So most of the time you find that radius can be from 0 to r, which is just radius, rho, d rho. Then the movement of theta can be from 0 to 2 pi, which is the actual, the 0 actually is the initial point to making the 360 degrees, and here 0 is the initial point of the radius to the radius, which you don't know, maybe it's infinity, maybe it's it's really a big number, maybe it's 10 or what, from 5 to 10. So a 0 is just representing the initial, or what, sometimes they can give you initials where they give you 5 to 10. So meaning where there's 0, you put 5, then where there's R, the actual one, you put 10. So here they haven't given us the actual now the actual what I can say the actual numbers where it has moved. So you have to just use 0 and R if you haven't been given. Like for this instance, they are just telling you to calculate each surface area. So yeah, so you continue. So it will be 0 to R, then 0 to 2 pi. So you know that yeah, you know that what you know that you know how to integrate to I think you know how to integrate the what the if you are given something, or yeah, if you are given for example 2x, those things, simple integration, you know how to integrate those things. So you know that if I integrate rho 0 yeah, uh, if I integrate rho in terms of 0, it means here, imagine there's a 1, you add another 1, it will be P2 divided by what? 2. This is a rule of integration. So if you have forgotten, you can just go through, like just watch some videos under integration. You understand it better. R 0 times, then this one, if you integrate d theta, if you just integrate uh, d theta, it will just give you theta and 2 pi 0. So you see here that it will be what? It will be r squared. Yeah, if you come down here, it will be r squared divided by 2 times 2 theta. Then they'll cancel out, then you have pi yeah, you are 2 pi, so you have pi r squared. And I think you know this formula. This is I think this is a common formula for you to find in. I think if yeah, in Zambia they just give us direct the formula, like they just give us direct the formula, the formula of finding uh the surface area of a disk. If you check in your book, secondary books, you'll find that this formula was just given directly. Yeah, this formula was just given. They give us directly, but there's a way of how to derive this formula. So the most important part of this coordinate actually is the how did this formula came about. So you learn how this formula came about. So yeah, you learn how this formula came about, and this is the formula which, if you are given information, you are able to calculate using this formula. So this is how the formulas they come about. So here, like actually, the most important thing is you knowing how to derive a formula, and this is how a formula is derived. So I would advise you. I'll send this a PDF for you guys to pass through it and to check how we did the integration and all those. And yeah, and uh, the 2 pi here is just a 360. I think you remember I had told you that the theta it moves around, making a 360 degrees. It moves around, making a 360 degrees. That's why I'm presenting it as 2 pi, and uh 0 is initial. Then r I don't know how it has moved out. I don't know actually the what the I can say uh, the radius in which it has moved out, initial 0, then it has moved to r. But sometimes they can give you, as I said earlier, sometimes they can give you the actual coordinates, or the actual numbers, and you do the what you do the calculation. So the most important thing is you knowing the formula. If you know the formula, you calculate anything which they have given you to calculate. So I don't know if there's any question here.
I have a question.
Okay.
So, like maybe we've been told to find the surface area of a disk, and we've been given like the information, like maybe we've been given numbers. We can just go direct to the pi r squared, right? Or we have to still show how we found the formula.
You have to show how you found the formula. You can't go direct to pi r squared. So here, like for example,
Question
yeah, you can.
for the integration of the theta.
Uh-huh. The integration of the integration of the
Yeah,
theta.
yes.
So basically, most of the time, that's what I'm saying. Like for this one, just try watching YouTube videos, because if I try explaining, I've spent a lot of time. So what you should know just is when you're integrating the theta, where I can say there's nothing here. If you see here, there's nothing. There's only d theta. When you integrate it, it will just give you a theta. It's just the same as d theta. Here on top there's zero because if you check these two, there's a difference between d theta and rho and d rho. Here there's rho, d rho, where it means I'm integrating what? I'm integrating rho. Yeah, I'm integrating what? Rho in terms of d rho. Here just the same as 1 d theta, where I'm integrating 1 in terms of what? D theta. So 1, you know that 1 which has uh, I can say which has no variable. You know, if you have, for example, if you have x is to the power 1. Then if you have a number which is just constant, is to the power 0. I think if you remember your secondary school, yeah, I know it's been long, so you just have to, yeah, it just have to be. I know it will be coming so. It will be coming so, and so it will be 1 to the power 0. So 1 to the power 0, you know that the formula uh, for integrating is x n plus 1 over n plus 1. That's the formula. I think you remember that formula. So it will be 1 to the power 0 plus 1 divided by what? 0 plus 1. So it's just the same as 1. So you see there that you have 1 to the power 1, which is just theta. You have theta. Yeah, you have theta. So this is how you differentiate the d theta. And when you have differentiated the d theta, now for you to reach to here now, you see here, for example, you do r. This since r there's r and 0, so you do r squared divided by 2 minus where there's rho, I place 0, you know it will be just 0. So it will be R2 divided by 2 minus 0, which is just the same as R2 over 2. Then 2 theta minus 0, which is just the same as 2 theta. This is where you see that it's just giving us 2 theta and R2 over 2. Then you just simplify, then you have theta R squared. Theta R squared. I don't know if it's clear.
Oui, c'est clair.
Okay, merci. Yeah, so that's all. Yeah, then there's also yeah, there's also there's also another question and another application. They can tell you to find the placement élémentaire d'un cercle de rayonnement rond. So they want you to find the movement élémentaire of a circle of rayonnement rond. And the rayonnement rho is just the distance from here to here. And they have said that rho is constant. They have said what they specify most of the time. If they haven't specified, you just if they tell you to find the surface area and they haven't specified that rho is constant, you just have to follow with this formula, and you go to, you have your answer which you are looking for. But if they specify that the rho is constant, it means that what happens, if you remember, what happens if you differentiate a constant? If you differentiate something which is constant, it always gives you 0. If I differentiate 1, it gives me 0. So it means that the differentiation of d rho is 0. So which means that if you see here, there's d rho. So it means that the differentiation of this d rho is 0. So it means that d rho, I will not include d rho because this differentiation is what is 0, is constant. I remove. So if they say for example, if they say radius is constant, meaning if there was d rho in equation of, or if there was a differentiation of that of that radius in your equation, you have to remove that radius. You will remain just with it. If you remove the radius, you just remain with it. The rho, which is constant, which is not moving, d theta. You just remain with it. This formula rho d theta, then d rho, you are going to remove it. So rho d theta. So this is the one which you are going to now integrate, and this one, the integration is just one integration because there's no other, there's no d rho which was changing, which is so because they said what is constant, and when it says it's constant, meaning the point is just moving in the same circle. It's not changing, it's not going out, but it's just moving in the same circle. And when it's moving in the same circle, we say that what changes is what? D theta, and the rho remains constant. That's why you are seeing R. R is just the same as rho. It's radius, so don't get confused. R what? Yeah, so R is just the same as rho. So you see that if you want here, you can just put rho. So you see that there's rho, which is constant, and there's D theta. So when they say rho is equal to constant, it means that the point is just moving in the same circle. There's no change more of the point. It doesn't make any surface area. It doesn't make something like a point doesn't move to another point. So for you to calculate this displacement, you just dp is equal to integral of r d theta, where we have said that rho, which is r, just the same as r, is constant. We just remove it out. Then you integrate 0 to 2 pi. The way we have done it, the first one, then you do your integration. Then you have is displacement elemental, which is 2 pi r. And I think 2 pi r is the formula to calculate what? Calculate the surface, the what? The diameter of
length
a
of a
circle.
circle.
The diameter of a circle, right? Someone has said the diameter of a circle.
The circumference of a circle.
The circumference of a circle, yeah. So yeah, you know those things. So this is the formula for calculating the circumference of the circle, and this is how you derive the formula. So basically, this is about deriving the formulas, and you have seen how interesting it is. Like you now know where these formulas, which you learned in secondary, which you didn't know where they are coming from. They're just coming. They just give you a formula, but you don't know where it's coming from, and you are just using a formula which you don't know where it's coming from, and now you have known where it's coming from. This is the interesting part about the coordinate polar. So those are the two examples. So that's how most of the time the questions come for you to find finding what the formulas. That's how the most of the questions come. So I don't know if there's any question here. Yeah, so I think it's clear. So we're going now to continue. Yes, you can ask.
So for this one, they can ask you to calculate the length of the disk.
Yeah, they can ask
which
you.
is the circumference, right?
Yeah, they can ask you to calculate the circumference of a disk. Yeah, they can ask you to calculate the circumference of a disk, and you have to, you have first to find the formula, and in that formula, maybe they can give you the radius, the core. You just replace the radius with the. For example, if they're giving you 5, you just replace on your equation, your formula which you have found, and you calculate your answer. So most of the time they assume that you don't know the formula. You have to find the formula, and after finding the formula, you have to use it to calculate what they have told you to calculate. That's how it goes. And electricity, basically the way it is, they are not more concerned on the final answer. They are concerned on how you have done your what, how you have derived the formula, or how you have done your calculations. That's what they are most concerned here, because because basically it's not you finding the final answer, but it's you doing the calculations and going the right direction. Each move you make is a point. That's how it is. Each move you make is a point in electricity. That's the good part of electricity. So if you try to omit the calculations and you go direct to the answer, you can just get a half mark or 0.5 mark, because you haven't done anything. For them, they think you haven't done anything. You just have to know how to get to the point, to the formula. So when it comes with electricity, pay attention on the procedures. They are really important. Yeah, so I'm going to continue. So I think with the coordonate polaire, it's clear. You guys, you have got, yeah, you have. I know it's even though it's not to the high level, but you have some ideas on this thing. And yeah, so now we're going to go to coordinates dans l'espace. Coordinates dans l'espace, yeah. So yeah, so for now, under coordinate polaire, you never have any difficulties. Yeah, because basically those are the things which you learn. Yeah, and you'll be using. So now when you go to coordinates dans l'espace, it's just the addition. So here I would not really spend a lot of time because it's just the same thing. So I will start with coordinate dans l'espace, where it is. We're going to start with coordinate Cartesian. So you remember we talked about coordinate Cartesian, and we said that coordinate Cartesian is defined by x, y, x and coordinate Cartesian Danzan plan is defined by what? X, y. So here use my x, y to find the movement, a movement of position of M. Yeah, we use x, y. Yeah. So under coordinate Danzan space, we just add z. So there's nothing complicated. From x, y, I just added the z. And here now, for me to find my point M, it means I have to pass by 3 ways. I have to use 3 points in other terms for me to have my point what M. So it's just the same thing which we talked about. And for me to find point M, so there will be X, Y, and Z. So for me to find point M, first of all, I have to move from initial O to X, and I have to move from initial O to Y. Then where this X and Y is meeting, I have to, even though there's no, but I have to draw a line which will touch where the X and Y is meeting here. I have to draw a line. Then when I draw a line, I just have to draw a line which is, if I'm given my point Z, I'll go on point Z and I'll just draw a line which is parallel to this line which I've drawn from O to the point where XY is meeting, which is parallel. I can just draw a long line. Then after drawing a line, I'll just go where toujours is always is where X and Y is what meeting. Then I draw a line which is what parallel to what? To Z. And where this line, which was parallel to O, and where XY is meeting, this where this line for Z and this line for where this line which is parallel to the line which is O, and where XY is meeting, and the line which is parallel to Z meet is your point M. So basically that's the point M. And for here, like this part is not really important. You don't even need to pay attention. Most like to spend a lot of your time here. What you have to know is that when you're calculating the vector OM, you from your OM is equal to X, EX, vector EX plus Y, EY vector plus Z, EZ. So I'm just adding what? Z here. So what is important is that under coordinate Cartesian, Danzan space, we add Z. That's what you have to just to know. Here, there's nothing like you have to know this diagram, all that. No, basically they don't ask you about come up with a diagram or that. No, you just have to know that is this point Danzan space, or is this point Danzan plan? So if this point is Danzan plan, you know that you are just dealing with X and Y. And if this point is in 3D or Danzan space, you know that you are dealing with X, Y, and Z. So you add X, Y plus Z. So here, yeah, I don't know if there's any question here. Yeah, so there's no question. If there's no question, we're going to go to coordonate dans l'espace. We're toujours coordonate dans un space, coordonate Cartesian, and now it's for you calculating déplacement. So for the déplacement elemental, it's just the same thing as Cartesian, coordinate Cartesian, but You just add what? DZ. Just add DZ. That's all. DZ. And it's just the same thing with the question which I gave you, the exercise one which I gave you, which you had the 3 points, and yeah, I think you saw how to do the calculations, all those things. So the displacement mm prim is just the same thing also. So here there's actually nothing really to talk about because they're just the same thing. So I don't know if you have got some question here or what, because yeah, because here just you are just moving from m to m prim, and you make something like a square. So you make something which is like a square, and yeah, and the most important thing is for you knowing this formula. If you know this formula, then you won't have any problems. So I don't know if there's any question here. Is there anyone with any question?
I have a question.
You can ask.
In the previous example or diagram, you mentioned something like when you reach this stage, you're not supposed to include the vectors. So even for this one, are we supposed to include the vectors or not?
When I said when I said when you're calculating the surface area, you don't need to include the vectors. So yeah, the surface area toujours, when you're calculating the surface area, the volume, you don't need to include the vectors. The EX vector, the EY vector, the EZ vector, don't need to add the vectors. But when you're calculating the movement, like in this case, the movement of mm prim, the vector mm prim, you here, like this is how the formula is. It is only an exception when you're calculating the volume and the surface area. You don't usually use the vectors, even when you're calculating the module where you use the formula for Pythagoras theorem, the square root, those things. You don't include the vectors. Yeah, you only include the vectors when you are told to calculate the déplacement élémentaire, mm. Yeah, I hope it's clear.
Yes, it is. Thank you.
Okay. Yeah, so we are always on coordonate Cartesian. So now, how do you calculate surface élémentaire? So this is where it's a bit different with yeah, I can say it's not really that much different, but there's just a small addition on 3D. When you're seeing things in 3D, there's just a small addition, which is actually it's not really complicated. So how do you calculate a surface élémentaire? You know that surface is only calculated with something which is in a plan. You cannot with something which is like with only you calculate the surface where there's only one face. What do I mean? I mean where there's, for example, where there's surface is mostly you do length times what? Length times breadth, something like that. You do length times breadth. Then for you to calculate volume is length times breadth times what? Times height. That's the calculation of the volume. So for you to calculate the surface area, meaning you have x, y, z, meaning you form something like a square. Then how do you calculate each surface area? Meaning you calculate the face of each cube. The face of each cube, you have to calculate each surface area. And how do you do that now? So there are ways in which you can calculate each surface area. So sometimes they can for example, they can tell you calculate the surface area of a point, or calculate the surface area of a face which is perpendicular at the vector EZ. How do you calculate the surface area of a face which is perpendicular to the point EZ? So you have to know where EZ is, you have to know where EX is, you have to know where EY is. So for you to know how to calculate your surface area, first of all, you have to take note of there's this line which is the X line. I think you have seen this line, which is the X line. They didn't do it deliberately uh, by extending the X line. If you have seen, if you check correct, if you check closely, there's an extension of the X line, which is cutting what? Cutting the face here. Then there's also an extension of the Y, which is cutting the face here. And there's also an extension of Z, which is cutting the face here. This is really important. I want you to what? To yeah, I want you to pay close attention here because this is really important. And they didn't do the extension deliberately. They did the extension because it has a significance which you're going to see. Yeah, you're going to see right now. So, for example, how do you know which surface is perpendicular at the vector EZ? The first one is ds is equal to dx times dy, perpendicular of vector ez. But how did they know that? I'm using the first, which is dx times dy. So the first, which is perpendicular to ez, is, first of all, you check your z. This is your z. If you have checked your z, this is your z. And this z, if you extend the z, is cutting this box here. If you can see this this rectangle thing here is cutting it perpendicular. That's why I'm saying the extension is really important. It's cutting it what? Perpendicular. So it means, if you have seen here, there's x and y. So it means for me to calculate the surface area, I have to use the formula, which is dx times dy, because z is cutting on what? X and y. So each surface area is what? Dx times dy. It's the same thing here for if it is perpendicular or vector EY. If it is perpendicular or vector EY. So EY, you check where your EY is. Your EY is here. Your Y is here. Then it's cutting perpendicular at this face here, which is there's X, there's Z. So this face here, the face here is defined in X and Z. So it will be dx times dz. So for me to find the surface area, I'll do dx times dz, which is dx times dz. Then you have which is perpendicular the vector ex. Ex, how do you do it for ex? Ex, you check where there's x, x is here. Then the extension here is cutting perpendicular at the first, which is between z and y, which is dy times dz. So for me to find the surface area to be ds is equal to dy times dz, which is, that's the surface area. So this is how you calculate the surface area. So most of the time you have to know. So these formulas actually, they don't really change, but there's times where you forget. Yeah, there are times where you forget. You have to know how to come up with this diagram. Then you what, you know how to come up with the formulas of you finding the surface area, those things. You know how to come up with the formulas. But if you want, you can just have it in your heart. You just know that if it is perpendicular on vector ez, I know I have to multiply with dx and dy. So what I can give you for you to easily memorize, or for you to easily understand, just know that if they say perpendicular of vector ez, just know that don't include z in your multiplication. If you have seen, don't include z in your multiplication. You have seen here, for example, they have said perpendicular on vector ez. You have seen there's dx times dy. Perpendicular on vector ey. You have seen there's what? Dx times dz. They haven't added dy. Perpendicular of vector ex. You have seen they haven't added ex. They have just done dy times dz. So that's the most simplest way where you can just have an idea, and you can just you can know it. Like you won't have any difficulties if you understand it like that. So I don't know if there's any question here. Is there any question? So basically, that's how you calculate the surface area. So these things, just have to know them by heart, and you won't have any difficulties. So now in calculating the volume elemental. So I want you to take note this. The volume is only calculated doesn't space in 3D. That's where you can calculate the volume. Doesn't plan. There's no. They will never ask you to calculate the volume because a plan it only has one face. But what 3D thing, it has three faces. So you are able to calculate this volume. So that's where the volume elemental comes in. And when they just tell you calculate the volume elemental of a cube, don't don't even don't even trouble yourself. It's just dx times dy times dz. That's all. Dx times dy times dz. Then you have the volume of a cube. So this is a length times breadth times height. Then you have the volume. So that's how you calculate the volume elemental. It's not something which is complicated. It's the things which you have already done in secondary school, Zambia. Yeah, they are just bringing dx, dy, and dz. So that's how you calculate this the volume elemental. I don't know if there's any question before we move on. Any questions? Yeah. So I can say under coordinate Cartesian Dozen space is just a rappel of, I can say it's just an addition. You just add the z, then everything just the same. So there's no need of spending a lot of time here. So now we're going to we are still on coordinate dozen space, meaning coordinate 3D. So now we're going to look at coordinate cylindric. Yeah, and I remember you guys, I told you that you should pass through these things so that I knew that when you are passing through these things, you won't have any difficulties because we have done a lot of things. Like, yeah, we've already looked at we've already looked at things which are similar to these things. So now we're going to look at coordinate cylindric. So definition starts. Pour obtenir le système de coordonnées cylindriques, il suffit de compléter le système de coordonnées polaires. So here, just saying that for us to get a coordinate cylindric, it is enough to complete the system of the coordinate polar. In other terms, the coordinate cylindric is the coordinate polar is the base of the coordinate cylindric, where you know how I think I have explained more on coordinate polar, where you know that the coordinate polar, it is you are only I can say is determined by rho, which is the radius, and the theta, which is the angle. So here with the under coordinate cylindric, where there's rho and theta, we just add the z. That's all. We just add the z. So it's a coordinate polar where you just add the z. It's nothing which is difficult. It's nothing which is complicated. It's something which you have done and we have already looked at. So you just add the z, and so here that's why you are seeing here they're saying the system the coordinate cylindric rho, theta, and z. So that's just saying the system of coordinate cylindric is defined by what? Rho, theta, and z. So here what I want you to pay attention is when we are in coordinate when you are in coordinate Danzian space on coordinate 3D, we have the coordinate polar. They are divided in two types. There's coordinate cylindric, where you just add the z, and there's a coordinate spheric, which you are going to we are going to look at after the end of coordinate cylindric. So the coordinate cylindric actually is I can say is it's not something which is really complicated. So you have rho, theta, and z. So it's defined by what? Rho, which, as I said earlier, is a distance, the radius, which is rho. Then theta is the movement of theta is the movement of when the point is moving. You see that there's a theta which is changing, which I've already talked about. Then Z is the distance from here to the point M. So here, the only difference is for me to reach at the point M, I have to move 3 steps, which means that I have to move a radius which is rho. Then after I move the radius which is rho, I have to move a height which is Z to get my M. That's one the difference. I have to move a radius which is rho at a certain angle which is theta, and a height which is Z for me to have my point M. That's what you have to note under cylindric. So cylindric is defined by rho, theta, and Z. So it continues here, says un point M de l'espèce est rappelé par un. So yeah, here I think I'd forgotten the bases. The bases associates E rho, E theta, and EZ. I think you know already about E rho and E theta. E rho, it defines it shows the direction of the radius. E theta, it shows the direction of the changement of the changing of the theta, and EZ, it just shows the direction of the Z, where the point, yeah, the Z, which is up. So yeah, that's it. Then un point M de l'espèce est rappelé par un un point M de l'espèce est rappelé par un rameau rho, which is OH. So it's just the same thing which I was saying, that this point M, for me to have the point M, I have to move the radius which is OH. Then I have to move a certain angle, theta, which is angle theta here. The angle entre the axe OX and the projection du rayon OM sur le plan XOY. So I have to move the angle, which is what? Theta, which is between X or Y. Then I have to move a height par rapport par rapport au plan XOY, par rapport au plan what? X or Y. I have to move a height, which is what? Z. Then for me to have my OM actually is just my OH plus my HM. My OH is the distance which is here, the OH, and it's just the same as the my OH is just the same as the when you're calculating the OM of coordinate polaire, your OH here is just the same as what as the OM of the coordinate polaire, which is rho, E rho. So it's just for you to be clear, if we go to coordinate polaire, for me to calculate my OM, I have to do rho, E rho, and you know why I said this one rho, E rho, because theta is 0. And I said that. And if you are not clear about how this what comes in, you can just go back to the video which I sent. So there's rho, E rho, which is for coordinate polaire. Then at this is when calculating OM of coordinate polaire, which is rho, E rho. Then to this rho, E rho, you just have to to this vector rho, E rho, you just have to if you check here the vector rho, E rho, we just have to add Z, Ez. That's all. Since we have said this one is 0, meaning this one to be out. So where there's rho, E rho, we just add Z, Ez. So I'm just what I'm saying is the coordinate polaire where we're just adding a Z. That's all. When I say coordinate, coordinate cylindric, just imagine the polaire, coordinate polaire. If they have told you to find the position of M, the vector or M, just imagine of the coordinate polaire. If you know the formula of a coordinate polaire, just add a Z there, plus Z, Ez. Then you have your what? Your formula. Then for me to calculate each module, use the formula for Pythagoras theorem, and this formula is just rho squared plus Z squared, and the rho is this distance here. So for me, you see that this distance here is it's between x and y, and it creates something like a triangle, and this triangle, for me to find this distance here, I know you remember the Pythagoras theorem is x squared plus y squared square root. Then I just said the add a what a z squared, because I'm doing in 3D, which is cylindric, coordinate cylindric. So you are just adding the z everywhere, just adding the z, and there's nothing which is really complicated. So I don't know if there's any question here. Any question before we move? Any question? Yeah, so if there's no questions, we're going to continue. So yes, you can ask.
Mm, since since we have OM as our vector, so is it possible to remove the angle here so that we just have the vector, the vector of the radius and the vector of the height?
Remove the angle so that you only have what? The vector of what? The radius and the vector of the height?
The radius and the vector. Yeah.
No, like the angle it's supposed to be there. Like for you to do a movement, I wish I was doing a physical art. But for you to do a movement, you have to there's an angle which is involved. So imagine, since it's impossible for us guys to do the physical learning is online. So imagine what's happening here. There's, imagine this point H. Yeah, do the imagination. Imagine this point H is here on X, this line on X. So for me to have this point M, there has to be a movement. So when H is moving here, when H is when H is moving here, is opening here, it means there's also like there's also a point here, like on Z here, there's a point which is moving. So you see that when H is making an angle of theta, that's why you see there's this line OM here. There's this line OM here. Is how can I say it? It's like the movement of theta is the one which is causing the movement of the detachment of M. Like this point is like is moving is coming out. So the point M is dependent on dependent on theta, in other words. So you cannot never leave theta when you are drawing when you're finding the point M. For you to find the point M, you have to have this angle, and this angle basically is the one which determines where your point M is. Yeah. For example, for example, for me to have, if in other terms I can say, if you have seen this distance OH is the same distance as what? ZM. Yeah, if you have seen this distance OH is the same distance ZM. So you can have a point on Z. Yeah, you can have a point on Z, and for me to have the same radius, it means I have to draw a line which is parallel to this line, or hash. So for me, yeah, so I have to draw. So the line ZM is parallel to what? Or hash. Then I just draw a vertical line which is parallel to Z, and where they are meeting, I have a point M. So for me to have my point M, I always need a certain angle. So you can never remove theta. Theta must always be there. I don't know if it's clear. Is it
I
clear?
have a question.
You can ask.
I just want to know something about there where there's at point H, there's E theta, E ho. What's the other E? E what?
Or there's EZ, since it's just following the Z here. There's
Okay, so
EZ.
even on top there also it's also EZ, right?
Yeah, they're just the same thing. They're just the same thing.
Okay, it wasn't clear. Okay.
Yeah, it's EZ, E theta, and E ho. So that's it. So, yeah, coordinate cylindric. So we are toujours on coordinate cylindric. So now we are going to look at what relationship is there between coordinate cylindric and the coordinate Cartesian. What relationship? So in other terms, is if I have to express it in x, x, y, z, how can I express if I'm given coordinate cylindric? How can I express x, y, z? You have to know. You have to know how to express it. So for this one, I think I had. So for this one, we're just going to look at it, how to express the first one. Then this one, the other one, you're just going to be doing some you'll be deriving, like I'll tell you how to derive, because the relationship, like the relationship between coordinate cylindric and coordinate Cartesian is not really important, like for you guys, but even we're just going to look at it for you, just to have an idea how to come about it. But we're not going to spend a lot of time here because it's not important for you. The important thing for you is the déplacement. How does the déplacement take place? That's where under coordinate cylindric. That's the important thing. So yeah. So since we're trying to move a bit fast, so I'll just explain a bit. I'd made something for you guys so that you understand this part very well, because it's a bit complicated. Yeah, it's a bit complicated. Coordinate freak. Did I? Oh, yeah. So yeah, so I made something for you guys. So for you to have how do you derive how do you find the relationship between, so you should know that here we're looking at the relationship between coordinate cylindric and coordinate Cartesian in three space. And coordinate Cartesian basically is coordinate Cartesian basically is we're going to look at the coordinate Cartesian, which is defined in X, Y, and Z, which is in three space. So how do you find the relationship? So you should know that there's error, which is error here. So if you remember our last if you remember, under the coordinate Cartesian Danzan plan, we had the OM is equal to XEX. I think you know that one. OM, for me to find the point M, is XEX plus Y AY. So it's just the same as error. I have error, so OH is defined by what? Direction error. So error and OH, I can say the vector OH and error here, they are playing I can say quite a similar role, in such a way that for me to have my error is equal to X, which is my X here. Yeah, X, EX. For me to have this point here, I have to move somewhere. I have to move my X, and I have to move what? My Y, my EY, to have this point. Imagine here there's a Y, here there's a X for me to have this point. So it will be X, EX plus Y, EY. Then for me to have, I know that X is equal to 1 times ax, and which gives me x is equal to O times where ex, if you should watch the previous video which we did, I said ex can be replaced by what? Cos theta, and there I just make cos theta the subject of the formula, and you should know that here ex we are using a module, and I said that a module of ex is always 1, so you have x is equal to cos theta. Then here also using a module of ey is equal to y is equal to sin theta. So it will be e rho is equal to cos theta ex plus sin theta ey. So this one actually uh, uh, you don't really need to know how it comes about, all those things. You just have to know what does E rho gives me in you have to know what is the relationship between coordinate Cartesian and coordinate what? Uh, uh, Cylindric. You have to know the relationship in E rho, and this is the relationship. So this one you just have to know it by heart. You just don't have to panic to how does it come about, or things. They will never ask you how does it come about, and they will never ask you use the formulas to find what. You just go direct to the formula. So you just have to know the formula for this one. For this one, just go direct to the formula. So there's yeah, there's no need for you to panic. Then yeah, that's it. Then for e theta now, for you to find as I said, for you to find e theta, e theta is just that you have to, I think you can see here, ona usi here down here. So for me to find my e theta, I just have to do my differentiation of e rho par rapport d theta. So I have to differentiate my e rho which I found here. So if you just know this one here, you won't have any difficulties to find your e theta. So this one actually, if they ask you what is the relationship between Cartesian coordinate cylindric and coordinate what Cartesian. So this is where you come in now. You have to know how to derive this. What you know, you have to know the formula is just not to know how to derive. So you just have to know the formula. So for you to have, if you know your E rho, you can have your E theta easily in such a way that for me to have my E theta, I have to differentiate my E rho in terms of what d theta. So I have to differentiate my cos, my sin, and yeah, my sine. I have to differentiate this, and you know how to differentiate this. And for you to differentiate this, I created like a form of a circle. So I think you guys remember this circle. So for me to if I'm doing differentiation, I'll be moving clockwise. This is clockwise, if I'm not mistaken. Yeah. So if I differentiate sine, it will give me cos. If I differentiate cos, it will give me negative sine. If I differentiate negative sine, it will give me negative cos. And if I differentiate negative cos, it will take me back to sine. Then if it is integration, if if it is integration, if I integrate sine, integration, I'll be moving anti-clockwise. That's why you're seeing this arrow. Integration is anti-clockwise. If I integrate sine, it will give me negative cos. If I integrate negative cos, it will give me negative sine. If I integrate negative sine, it will give me cos. If I integrate cos, it will give me sine. So this you just have, I'll send the PDF. You just have to check the like a diagram, and you won't have any difficulty. So for example, for example, for this one, for e theta. So e theta, here we have said that we have to differentiate e rho par rapport à d theta. That's what we have said. So there's your e rho. E rho is equal to cos theta ex plus sin theta ey. So if I differentiate cos, I said I'll differentiate sine to cos, cos to negative sine, sine to negative cos to sine. So if I differentiate cos, it will give me negative sine theta ex plus, if I differentiate sine, it will give me cos theta ay. So this is how you come up with e theta. So you don't need to panic or uh to to take a lot of time when they tell you to what is e theta, like E theta in relationship of coordinate cylindric and coordinate Cartesian. You just have to know how to differentiate it. You can also differentiate if you are given E theta, then they tell you to find E rho. You can just differentiate E theta in terms of theta, and it will give you negative E rho. So it means if I differentiate negative sign, it will give me negative cos, but there's a negative here. So negative cos times negative, it will give me cos, which is cos EX, plus if I differentiate sign, it will give me cos. Then if I differentiate cos, it will give me negative what? Negative sign. The negative sign times negative, which is here, it will give me positive sign, which is this formula here. So this thing here down is important. You have to know it. So here, don't need to waste a lot of time. We don't need to waste a lot of time because this is not really important. Yeah, you just have to have an idea and other things. Yeah, so I don't know if there's any question here. Mafunso, is there any question? Yeah, so if there's no question, we're going to go to coordinate cylindric. So you have seen that these things are actually they are simple things like if you understood the coordinate polar, you won't have any difficulties with it. This coordinate cylindric because it's just the addition of the coordinate polar, it's just the addition of the coordinate Cartesian, yeah, those things. So you won't have any difficulty. So now we're going to talk about the déplacement élémentaire. So déplacement élémentaire is the one which is really important. So under déplacement élémentaire, even it is just the same thing with the déplacement élémentaire de coordonnées polaires. So under coordonate polaire, we had this formula. Where's coordonate polaire? Yeah. So under the déplacement of coordonate polaire, we had this formula: rho plus rho times d theta e theta. And I told you how this comes about. I told you remove first the theta without changing the rho, which is rho times d theta, and after that you move to point m prime. So if you know this formula, then you add plus dz, then you have found the déplacement of what? Of a coordinate cylindric. So it's just the addition also for this one. It's just the addition. If you check here, there's zero, which is found in the same way in which I've told you. So first of all, you have to move. You have your m prime here. So you have to move. First of all, you have to move. You have to move rho. Yeah, you have to move theta without this distance, which is rho. If you have seen you have moved. It's like you're moving on the same circle where the distance OM doesn't change, rho doesn't change. This is the rho. This is the rho, and the d theta change. This is the d theta. Then after that, you have to move. You have to move like you are going outside, which is the d rho, which changes here. You have to move as if you are going outside. Then after that, this point it has to move as if you are going up to have your m prime, which is what the dz. That's what I'm saying. They're just adding the dz, which is the movement, the vertical movement up. So if you are told to calculate the displacement élémentaire of a cylinder or a cylindric shape, you have to know that you just have to add a z. A z is just a movement of the vertical movement for you to have m prime. So how this point moves? It moves. How this point moves? First, it moves d theta, and after it moves d theta, it moves zero changes, and after it moves zero, it moves dz to have m prime. So this basically is the formula where you just add what? The dz. So I don't know if there's any question here under déplacement élémentaire. If there are questions, ask me so that we are clear on this one.
We just explain once more on this part.
Okay. So I'm saying coordinate cylindric is just the same as coordinate polar, which we have already looked at. So how do I find this displacement elemental? So I can ask you calculate the displacement elemental of M to of M and M prime. So the displacement of a point from M, the movement of a point to from M to M prime. So how does this point move from M to M prime? So I have to know how to calculate. I have to know how to do the calculation. So for me to find my formula now, for me to find my formula of the displacement, or in other terms, the movement of M. So how does this M move? So this M to reach M prime, for it to move, it doesn't move in hazard like anyhow. It has to follow steps in movement. So how do I move it? So this M moves first in changing. So this is the M, it moves. If you check here down, this is the M which moves. So we see here that there's a theta which is changing, d theta, but you see that this point is moving in the same circle. There's no movement of outside or going inside. So this circle is moving, is moving in a circle. So we see here that the rho is still the same. What changes is what? D theta. So it will be rho, which is the same, times d theta, e theta. This is the first part here. Then now, for me to have to reach to this point, I have to move like I'm moving outside here. I'm moving outside. So here, when I'm moving outside, meaning I'm moving from the inner circle, I'm moving outside the circle, meaning the radius increases. So there's the change more of d rho, which is just the radius, the changing of the radius. So you have d rho, e rho, which changes. Then from now, I'm at this point here where it has changed. It has yeah, where there's a change. So now from this point here to going up now to my M prime, my final stage, I have to move this Z line. I have to move vertically, which is, you see that there will be a changing of Z, which is dz times Ez. This is where this formula is coming from. So if they tell you to calculate MM prime or DOM or DL, you have to know that the placement elemental, you have to know that this is the formula which you use, and this formula is always the same. You just have to have it by heart. Yeah, but also you have to know how does this formula come in, and have yeah, that's the explanation. So I don't know if you are clear on this one.
Oui.
So that's how you do the displacement, the one. So basically, most of the time, question they specify, uh, yeah, they specify calculate the surface area of a point in a surface cylindric or in a what? Yeah, surface cylindric. So you have to know which formula I have to use if it's surface cylindric. So they specify which shape you are calculating the its surface area. Is it a cylindric shape or a Cartesian shape or a spheric shape? So they specify most of the time. So you just have to know the formulas. So now, how do you calculate the surface elemental if they tell you to calculate the surface of a cylinder? How do you calculate the surface of a cylinder? How do you come up with the formula of a cylinder? Or how do you, how do you calculate the surface of a cylinder? So when you're calculating the surface of the cylinder, there are keywords which you have to take note of. And if you take note of these keywords, you'll be able to derive the formula very easily, and you'll be able to come up with the formula which the professor is looking for. So, the first one, when we consider that, so the first one, they can tell you that calculate the surface lateral. Yeah, they can ask you to calculate the surface what? Lateral. Yeah, the surface lateral, it means just the lateral surface. Uh, in other terms, I can say uh, um, the surface which is the side surface, I can say so in other terms, the lateral surface. And if they tell you to calculate the lateral surface, they mean there's something which is constant here. So sometimes they can tell you calculate the surface lateral, or sometimes they can tell you calculate the surface of the cylindrical surface where rho is equal to what? Constant. So how do you calculate the cylindrical surface when radius is equal to constant? What do I mean when radius is equal to constant? So this one is here, that's where they explain it very well. So here they say just the same thing. So they say calculate the surface lateral. So when they say surface lateral, you should always know that when they tell you to calculate the surface lateral of a cylinder, they are specifying that the radius, which is the diameter rho, is constant. When I say the radius is constant, I mean that for example, this is my point M, and this is a cylinder. Imagine this is a cylinder. This is my point M. So when I say rho is radius, it means this point, for me to calculate the surface area, this point M can never move out of the cylinder, can never, like moving out of the cylinder, I can say moving, for example, imagine you have two cylinders. There's a cylinder inside and there's a cylinder outside, the bigger cylinder, which is covering the cylinder inside. So when I say rho is constant, it means the point will never move outside the other cylinder, which is big. So it will just move, it will be moving around the circle, and it can also move up. So it will be moving what? Around the circle, where I'll be seeing that it's only d theta which is changing, and the rho is constant, times dz, which is m prime. So in other terms, when they say surface lateral, you just have to go back. If you have forgotten how we move here, you just have to go back to this formula. If you know this formula, for you to calculate the surface is only d rho times rho d theta, times dz. But for you, you know that surface is always you only always use 2 points, the length, and this what is a pretty big. Most of the time, you usually use two at 2 points. So for me to calculate the surface area, is either I can do d rho times rho d theta, or rho d theta times dz, or the other way around. So for you to know which formula you are using, they give you a hint most of the time. When they tell you to calculate the surface area, they'll tell you calculate the surface area lateral. When they say calculate the surface area lateral, which is the surface area which is in the side, or calculate the surface area with the rho which is constant, it means that the differentiation of the rho here, it will give you a 0. So meaning this one you not consider it, d rho, you won't consider it. So only consider rho d theta times dz, which is the formula here. You have seen there's rho d theta times dz. Then this one, the arrow, for this one is just showing that it's just the same as how can I say it? The arrow is just showing that the surface area is vertically to is perpendicular to arrow. If you remember under Cartesian, this here, if you remember under Cartesian, we said the ds is equal to dx times dy, which is perpendicular to what? Ez. So you always put which is not in the what, which is what, which is not in your calculation. So here I also want you to note. Though someone asked me a question, do you include ez, rho, and do you include the vectors? For under, you should note this one, under 3D, you only include basically in actual sense, you don't need to include the vectors. But under 3D, you include the vectors which is not included in your what? In your calculation. For example, Ez, you include it. This one, the Ez is just showing that the surface is perpendicular. So the vector which you include here is not basically the vector which you consider in calculation. No, it's just showing you that it's perpendicular. So the vector here, they only add the vectors here to show that it's perpendicular. But under the diagram plan, you don't need to include the vector because uh, they are only, I can say there's only x and y. But for this one where you have 3 points x, y, z, you have to include the vector which is not included in the calculating of the surface. We just show that it's perpendicular. So it's the same thing here. It's the same thing with with here. If you have seen here, we have said that if you have seen here, we have said that rho is what is constant, which means that d rho it will give you 0. So it means that you don't include d rho. So which vector are you going to use? You are going to replace by vector e rho. Then they can also tell you to calculate the surface of a base. They have given you a cylindrical figure and they tell you to calculate the surface of a base. How do you calculate the surface of a base? So when you see the word surface of the base surface, you should know that they are meaning that z is what constant. They want you to calculate the surface which is created on the surface, meaning you are not moving up or you are not moving down. You are just on the surface. It means you can move outside the circle or you can change the angles, the theta. You can change the theta. So there they are just meaning that z is constant. So if z is constant, meaning the differentiation dz is equal to 0. Differentiation what? Dz is equal to 0. So if you go to your equation here, it means dz is equal to 0. So your equation will just include d rho, your surface area will just include d rho times d theta. Yeah, then you just include the vector ez because z is not what included here. So this is the formula here. So you have seen here, there's no movement up, there's just movement outside. This is the same thing where z is constant. There's just movement outside, which is d rho times rho d theta, which is the change of the radius. Yeah, so you have seen if they say surface of the base, you are not moving up, you are just moving d rho and d theta. That's why you have seen here that your surface of the base is equal to rho times d theta times d rho times ez, meaning it's perpendicular to the surface what ez. That's why you are seeing this arrow here, meaning it's perpendicular to the surface what ez. So I don't know if there's any question up to there before I go. Is there any question?
Could you please repeat what you just said? Like starting from this
where the radius is constant.
Yes.
Oh, okay. So here we are now on surface elemental. How do you calculate surface elemental? So I said earlier that you have to have there are specifically words which you have to take note of. When they say surface lateral, they say calculate the surface elemental of a surface lateral. It means calculate the surface of a side, the surface of a side of a cylinder. So how do you calculate the surface of a side of a cylinder? So for you to calculate the surface, when you hear surface lateral, you should always be noting that they are meaning that the radius is constant. The radius is constant in such a way that it's not moving out of the cylinder, the other cylinder. It's not moving out of the cylinder, but it's in the same cylinder. That's why I said, imagine you have got 2 cylinders, which is there's a small inside and there's a small one and the big one, which is outside. So you see that when I say calculate the surface elemental of a small circle, which is inside, it means that I want to calculate the surface, I want to move away from that small cylinder which is inside. I want to calculate its surface, like its side surface. There's no there's no moving to the outside circle, to the outside cylinder which is big. To the outside bigger, I can say to the outside bigger cylinder. So I want to move to the bigger cylinder, but I only calculate the surface area of the cylinder which is inside. So how do you interpret that one? So it's just the same as I said. if I say calculate the surface lateral, you should know that rho is constant. When I say surface lateral, what you should note is that rho is what? Constant. And when rho is constant, it means that the distance between the point, I can say the point O, which is here Z, the point O, to the point M is always constant. It's always constant, and the only movement which I'm allowed to move is the movement of changing the angle, which is d theta, where the rho is constant, and the movement of changing the dz. So for me to calculate the surface is rho times d theta times what? Dz. That's how I'll calculate. And I said that E rho here is just showing that is what this surface here, which I'm calculating, is perpendicular to this vector, which is E rho. That's why I'm saying this vector is coming outside here. This vector is coming outside here. So for you basically to calculate each surface area, you just have to note that if they say lateral, they mean rho is constant. And when they say rho is constant, the d rho is equal to 0. That's what you should note. So that's why I came to this equation. I said they mean, if they say surface lateral, they mean d rho is equal to 0, meaning this equation here, I'll remove it. I won't consider it. So I'll just calculate the surface using this equation times this equation. So if you see here, it's the same thing. It will be, because you know that if you differentiate the constant, it will always give you a 0. It will be rho times d theta, which is the second equation, times dz, which is the second, the rho d theta, which is the first formula. The second formula, sorry, and dz, which is the second, the third formula, times a rho, which shows that this surface is perpendicular to this surface is perpendicular to the vector A1. Yeah, so this is how you calculate the surface lateral if they have told you to calculate the surface lateral of a cylinder. Then I said for you to calculate the surface of a base. The surface of a base basically it says of a cylinder, that means the surface of something. A base, you know, base is something which is the down part of something. I can say the flat part of something. If you see here, when I say base, I mean I just have to calculate the surface area of the flat part, the flat part of something. Meaning I don't need to move up, which is the vertical movement. I just have to move what? The down movement. So which down? So it means that z is equal to what? Constant. Meaning why z is equal to constant? Because I'm only calculating for the base. I'm not calculating for the vertical. I'm not calculating the surface area of what? A vertical. And if z is constant, meaning I cannot move up. When they say surface of base, it means I cannot move up. So for me to calculate each surface area, it means my dz, you know, if you differentiate something which is constant, which is I'm not moving, meaning my dz is constant, it will give me 0. So my dz, I'll exclude it from my equation. So I'll only have these two equations here. If you check here, if you check here, there's 0 times rho d theta. These are the two equations which I'll have. Dz, I won't have it, because the differentiation of dz, it will go at 0. Yeah, so in terms of a diagram, you see here that you can only move outside the circle, which is 0 times, you can also change the angles, which is rho d theta, where the rho never changes. So you can move rho d theta and you move out, which is d rho, which is rho d theta times d rho, and ez, it means the vector which is perpendicular, just showing that the face is perpendicular to the vector ez. Then now how do you then also you should also note that they can also tell you that the theta is constant. When theta is constant, you should know that where there's theta it is giving you 0. So for me, basically what I do most of the time, I don't take a lot of time imagining the diagram, the word. So for me, basically, if they say that theta is constant, I know that d theta is equal to 0. So I know that 0 times rho, this whole thing is 0. So I know that for me to find the surface area is 0 times dz. That's how I can find the surface area. D0 times dz, which is perpendicular to what? E theta. Unfortunately, under my notes, we only have for z is equal to constant and rho is equal to constant. But there are some times where they tell you theta is equal to constant. I don't know if there's any question there. And the one who had asked me a question, is it clear?
Yes, it is.
Okay. So yeah. So we're going to end here since it's time up, and I know you guys you are tired. You are tired. Yeah. So we're going to just end with the coordinate cylindric. Yeah, the coordinate yeah, the coordinate cylindric. So we're still on coordinate cylindric. Now, how do you calculate volume elemental? So volume elemental is not something which is really difficult. So for you to calculate the volume elemental, you see, you have moved, as I said earlier, you have changed the theta, which is rho with the radius not changing. So you have rho d theta. Then you have is what after you have first of all you move for you to have m prime, as I said earlier. First of all, you change the angle. You move by changing the angle, which is without changing the radius, which is rho d theta, which is this movement. Then after that, you move the this is the length where you change the radius. You move like you're moving outside the circle, which is d rho. Then after that, you move the dz. So you have got the secondary mathematics. If you remember, you have got the rho. Yeah, you have got the d theta. Sorry, you have got the width, which is rho d theta, and you have got the length. You have moved outside the length, which is d rho, and you have got the height, which is dz. So for you to calculate the volume, you just use rho times d theta times d rho times dz. So this is the formula of the height, and it's not really difficult, like for you to understand and to memorize all that thing. So it's you should always know that the radius is always in between 0 and the radius is always in between 0 and r. It means it can be any number, which is can be maybe infinity, all those things. Then theta is in between 0 and 2 pi. 2 pi actually is 360. Then z is a height, which is between 0 and what and ash, which is z, which is the height, any height which you are given. So this actually they're just telling you where you can like is limit, all those things. Yeah. So I don't know if there's any question here.
I think I have a question.
So I have a
Can you
question.
just clarify something?
Mm-hmm.
The radius, you said it's rho, right?
Yeah, so yeah.
Then what's rho by d theta?
I said the radius is rho. Yeah. Then I said for you rho times d theta is imagine you have forming closely, there's this point M and there's this point M prime. So there's this point M. For me to reach M prime, I said there are steps to follow. You don't move in a hazard manner, or you don't move anyhow. There are steps which you have to follow. So I said for you to reach to M prime, you have to move from M to to this point, to like there's a change in, I can call this point, I'll call this point J. So you have to move from M to J, where you see here that there's a change more of, if you check, if you check down here, there's a changing of the angle. There's a changing of the angle. But since this point M is moving in the same circle, it means the radius still remains the same, which is rho. It still remains the same. And what changes is what? D theta, which is D theta. So here there's a point M to this point here, which I can call J, which is where you see that there's on the change of the angle, where there's a change of the angle, but the radius remains the same. Then from there, from the J, you move outside. You move like you're moving outside the circle, where you see that there's only the changing of the what? The rho, which is the d rho here. The radius changes. That's where you see the changing of the radius, which is d rho. Then from this point, the moving outside, I can call this point K. Then from this point, going up, going up to my final point, which is M prime, I have I only change the what? I only change the Z, which is the DZ, which is the M prime. So if you basically the rho d theta is just a changing of the angle where the radius remains constant. I don't know if it's clear. Yeah, so I'm planning to
I do have a question.
Yeah, you can ask your question.
Okay, yeah. So in quotation coordinates, we treat the area as a scalar quantity because we don't show the direction, like. But say in cylindrical coordinates, we do consider the direction in which the displacement is taken. So is it always necessary to show the direction after I've found my final answer for the area in a cylindrical coordinate?
Oh, okay. Yeah, that's a nice question. So for cylindrical coordinates, I can say for coordinates in dance and space in general, when you're finding the volume, you don't need to show the direction. If you have seen here the equation for volume, there's no direction here. You don't need to show the direction. Then when you're finding each surface area, you only have to show the vector of the vector which is perpendicular to that surface. And for you to find the vector, for you to know the vector which is perpendicular to that surface, you have to first to check which variable is constant. If it's radius which is constant, meaning you have to use the vector E rho. If it is the height which is constant, the Z which is constant, you have to use the EZ, the vector EZ. If it is the what? If it is the width, which is for example, if it is what? If it is the theta, sorry, if it is the theta which is constant, you have to use what? E theta is vector, and the one which is constant is always 0, so you don't include it in your calculating of the surface area. Where you don't include where there's a, like for example, where there's a differentiation, since you know that a differentiation of a constant is always 0. So that's it. So even for Cartesian, when you are told to calculate the volume of coordinate Cartesian, you don't include the vectors, the direction. But when you're told to calculate the surface area, you have to check first which point is constant. If they tell you that x is constant, it means that the dx is equal to 0. So you only calculate the dy times dz with the vector ax. I don't know if I'm clear on that one.
Yes, very clear. Understood.
So that's how you go about it. Yeah. So I don't know. Are you guys really tired or what? I want us to tell me if you are tired, because if you are tired, you can stop here so that you rest for your another call. I know that you had a busy day today. Yeah. So under coordinate Okay. Yeah. So we'll end here today since you guys were tired. Then I'll try to send some exercises. I'll try to send exercises, and this exercise, uh, uh, you should try it. It's the things which you have done, actually, these things which you have done. So you should try solving it, and you should send answers. And you should also know that this exercise which I'm giving you, we'll never do the revision together. I'll never, like before teaching, I'll never do the revision. So the revision is in my inbox. So if you send me the answers, I'll tell you how to do it. If you didn't get it right, then it ends there. Then those who don't want to do it, yeah, you are actually bad not to do it. But the deadline is on 20, when before we meet on what, on Monday. That's the deadline. So those who want to do it, they'll do it. I have no problem with those who don't want to do it, because it's a free will thing. You do it or don't do it. But for me, I would advise you to put an effort to do it. Just try doing it, and just try solving it, and you send the answers. Even if they are wrong, it's fine. That's how we learn. That's how we learn. Even yeah, we get something wrong, and yeah. So make sure you do the exercise which I'll give you, and you should do. Those who are not there should tell your friends that we'll never do the revision. The revision is in my inbox, and when you're sending your exercise, send on WhatsApp, not on Telegram. Telegram, basically, I don't use Telegram. I just use it for sending videos. Yeah, so send on WhatsApp, in my inbox WhatsApp. Then I'll reply you. Yeah, if you send me, I'll check your exercise and I'll reply it. Yeah. So have a nice day. Yeah, have a nice day. We'll meet on Monday. Yeah, and enjoy the rest of your lessons.